Managing bottlenecks in service processes. Bill's Barbershop has two barbers available to cut customers here. Both barbers provide roughly the same experience and skill, but one is just a bit slower than the other. The process below shows that all customers go through steps B1 and B2. Here's steps B1 and B2, and then can be served at either of the two barbers as step B3. Here are the two barbers as step B3. The process ends for all customers as step B4, which is over here. The numbers in parentheses, these numbers over here, indicate the minutes it takes that activity to process a customer. Okay, so let's go through our process flow more in detail. The image on the left is basically a snapshot I've taken from the chapter, and what I've done is I replicated this in Excel over here. And the reason behind it is that when solving problem, it's much quicker and easy to do it in Excel. So our first question is that how long does it take the average customer to complete this process? So this would be fairly simple. You add up all of the minutes and you should get your average time. But how do we do it? Is that we add 8 minutes of B1, 10 minutes of B2. In our step B3, because it's a single step with two different options, barber A takes 15 minutes and barber B takes 10 minutes. Over here we'll be taking the average. So we'll be adding 15 and 10 divided by 2, and we get that average number that would be added. And then finally we'll be adding the last step, which is 9 minutes of B4. So this is how to do it. 8 minutes of B1 plus 10 minutes of B2 plus, and now we need to take the average, 15 plus 10 divided by 2. This will give our average, and then finally adding 9 minutes of B4. 39.5 is our answer. Coming to the second question, what single activity is the bottleneck for the entire process? Now remember, the bottleneck is the process or step or workstation with the lowest capacity. The lowest capacity to handle the number of customers. So the more time is in a process, the lower the capacity. So we have 3 over here processes, B1, B2, and B4. And it takes 8 minutes in B1, 10 minutes in B2, and 9 minutes. So 10 is the highest. Therefore, our answer would be B2. Our third and last question is, how many customers can this process serve in an hour? So we need to see the bottleneck process, which we found in our earlier question, that was B2. And we need to find out how many customers can this process serve in an hour. So we would simply convert 1 hour into 60 minutes and then divide it by the bottleneck process, 10 minutes of that process. So our answer would be the shop can handle 6 customers per hour. That's the end of question 1.